Okay, last time we talked about ionic compounds. Today we're going to talk about molecular compounds. In the previous example, we looked at compounds which are atoms coming together because one atom wants to lose electrons, and another atom wants to gain electrons, so they come together and they form an ionic compound. Well, sometimes we have compounds that come together because they share electrons. So there's no exchange of electrons here. Here they share electrons. And this is a little bit trickier when it comes to figuring out names and formulas because if you remember with ionic compounds, you use something called a crossover rule. But with molecular compounds, it's a little bit trickier, and you have to use prefixes. And I'll show you what I mean. So here I have 6 prefixes. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6. Now, if you recall, with the previous example with ionic compounds, you use the crossover rule. So again, just to review, if you had lithium, which is +1, and you had oxygen, which is -2, you used the crossover rule, which would have predicted you need 2 oxygen and 2 lithium and 1 oxygen. Here, there's no charges, so it's different. What we have to use here are the prefixes. So for instance, this compound over here, this would be called nitrogen dioxide. So it's in the prefix that we actually derive the formula. So if I said to you, this compound is nitrogen dioxide, I'm telling you that it has 1 nitrogen atom and 2 oxygen atoms. And again, the second element, its last name, the ending, does change to IDE ending. Now this one, you can see it has 2 nitrogen, so I have to write, in this case, dinitrogen. And this is tetroxide. Alright? So again, if I say to you, this is a compound's name is dinitrogen tetroxide, I'm telling you that it has 2 nitrogen and 4 oxygen. This one would be dinitrogen, okay, pentoxide. So again, this is telling me that the compound has 2 nitrogen and 5 oxygen. This is carbon monoxide. This is carbon dioxide. So you notice that if the first element has only 1, you don't need to write mono, carbon, monoxide. It's implied that if you don't say mono for the first element, there's only 1 of them. Okay. This one is carbon tetrachloride. Okay, and this last one over here is phosphorus trichloride. Now, there are some exceptions to this naming system. Well, not really exceptions. Like, for example, it would not be wrong to call this carbon tetrahydride, but some of these have official names. So, for example, this is methane. This is not trioxygen or trioxide. This is actually ozone. This is not dihydrogen monoxide, although you could call it dihydrogen monoxide, but it's water. Okay. So what I'm saying is you can call it dihydrogen monoxide, but no one does. They call it water. And this other one over here is ammonium. Again, you could call this nitrogen trihydride, but it does have, ammonia, not ammonium. Ammonium is NH4 positive. This is ammonia, which is NH3. So again, you can call this nitrogen trihydride, but it does have an official name, ammonia. Okay. This is not dihydrogen. This is just hydrogen because it's only got 1 element in it. So it's not a compound really. It's just an element that's stuck together with 1 of its own. So this is just chlorine. Okay. This is just oxygen. And this is just iodine. Okay, so just know some of these exceptions or some of these common or official names. Now, we can go backwards. So if you have the name of the compound, you can actually derive the formula. So for instance, if I have this, which is dinitrogen monoxide, then I know I need 2 nitrogen and 1 oxygen. This is carbon disulfide. So this is, again, there's nothing in front, so I'm assuming this is 1. And there's 2 sulfur. And this is diphosphorus, so it's 2 phosphorus and 5 chlorine. And again, nothing here, so this is 1 arsenic atom and 3 bromine atoms. Now, the other thing that I forgot to mention is you may have noticed one difference, big difference between molecular and ionic compounds. With ionic compounds, if you recall, if you have a compound and the charge is the same number in terms of, for example, if I took calcium and oxygen, and this is +2 and that's -2, what we could do is we could reduce it to calcium oxide, right? Because you would have 2 and 2, and that would reduce. But with molecular compounds, you don't do that. So in other words, you don't take this compound over here and reduce it. That would be a mistake, okay? This does not become NO2. Do not do that, okay? This stays as N2O4. So that's a huge difference. And that's why we need the prefixes, because it's very difficult otherwise to figure out the formula. Okay, so that's it for molecular compounds.